I would say we had good traction with the innovation stuff. And it's similar with fundraising, with customer business development. It's just building the relationships, finding who we need to know to get to the next phase. I think one of the challenges that we've seen, or something I've learned through this process, is it's more siloed than I expected.
Hey, everyone, and thanks for listening to another episode of DIB Innovators. Today, I'm speaking with William Kowalski, COO and co-founder of Atomos Space. William, thanks for chatting with me today.
Yeah, pleasure to be here.
Yeah, this is going to be exciting. Love what you guys are doing. But for the listeners, can you tell us about your background and, how did you find yourself as a co-founder of a space company?
Yeah, so I've had a fairly eclectic career. I actually started my professional life in funeral service, which I did for a little over a decade in New York. And then I ended up moving into finance, then came out here to Colorado, worked with a small team. We managed a little over $500 million in client assets. I had some clients in aerospace, Colorado being such a big aerospace state. And that's how Vanessa and I first met. Vanessa, co-founder and CEO of Atomos. She at the time was working at Lockheed. She was the chief engineer and program manager for the propulsion system on the Orion capsule. And the concept of what we're doing really came from some of her work in a previous job before she was at Lockheed. And her and I were introduced. She was looking for a business partner. I used to run a physics website back in the day, just kind of went all over the place, different way and professionally. And when she talked about what she was looking to start, I love the idea. A few months later, we started working together as co-founders. And then about a year after that, almost a year after we had that first dinner, we ended up getting married. So we are a married co-founding team, and we now have 2 kids, 40 employees, and 2 spacecraft in orbit. And essentially what Atomos is doing is trying to expand what's possible in space. We really want to create the logistic spacecraft or the freight trains of the solar system to make space a more dynamic environment than it is today.
It's great. Well, I have a lot of places I could go off that introduction. Like, what lessons learned in the funeral industry are you able to bring to this? But oh, then again, it's entrepreneurial, it's leadership, I'm sure, just how to run a business. And you've crossed how's that family dynamic? I mean, we are a unique company as well as I have 2 other co-founders, they're brothers, and one's like, you're mixed, and he's my best friend from high school. So like, you're mixing friends and family, and that's always the big no-no.
Yeah, I think for us, we're in a fortunate position that we started as co-founders. So that was the initial thing. We were business partners, and it's helped us be very good at separating the 2 of them. We could certainly have arguments as co-founders or as 2 executives of the company. And then, on our way home, be like, what's for dinner? It's really good at separating the 2. What also helps is she's very good at her set of things, and I'm very good at my set of things. And they are pretty different, and we do balance each other out quite a bit. She is definitely more of the optimist of the 2. I'm more of the pessimist and downside planning and what's our contingency. We kind of cover each other that way.
Yeah, well, that's great. Well, it's cool that you're able to figure it out. And yeah, the startup world, it's 24/7. So it's also helpful, I'm sure, to have you guys are aligned every day on what you're doing. So fantastic.
Yeah, we can certainly have a lot of business discussions during dinner.
Yes. So let's unpack a little bit more, with your company on how do you envision and what do you guys bring in order to expand what's possible in space through, your vehicles? What are you developing? Like, how does that look?
Yeah, so the spacecraft we are developing, the industry jargon for it, or acronym, I should say, because space and national security loves their acronyms, is OTV, or Orbital Transfer Vehicle. So these are spacecraft that are designed to rendezvous, capture, and then relocate other spacecraft. So that there are 3 critical technologies that we are doing to realize that. The first is rendezvous, proximity operations, and capture. So we have our own 5 degree of freedom test bed we built in our facility here in Broomfield to do ground demonstrations. The next part of that is power systems. So we need to be operating at a very high power level. And then the last is propulsion systems. And kind of bringing all three of those together into a high powered spacecraft is how we're able to zip around and move other satellites that aren't really designed to move a lot in space.
Okay, so let's break that down a little bit then. So your vehicle, the first one is, rendezvous. What are the challenges in that technology to be able to rendezvous with another, very high valued asset in space?
Yeah, I mean, probably the biggest one is, once you get to the final approach, it is knowing what you can and can't grab onto. There are a lot of very delicate components on spacecraft. There are a lot of things that are not meant to be load bearing at all. And then our clients themselves can be operating at the time of service. So it's not interfering with their power generation, shading their solar arrays or interfering with their radio if they're trying to communicate down to the ground. And really marrying all of that while you're very distant from the spacecraft. So our space, they're operating in geo, there's latency, there's lag, there's imperfect information about even where our client is. The second part of that, and this is more true, it's true in commercial and national security, but probably a little bit more true in national security, which is to really interact with the client, we have to know about the spacecraft. And people don't really love giving up proprietary information about their spacecraft and its design specifications. So one of the things we've developed in-house is a lot of machine vision, character recognition, so that we can autonomously figure out this is a safe thing to grab, this is not a safe thing to grab.
Interesting. So then if I just talk through this mission, do you have any in orbit right now?
So we launched our first 2 spacecraft in March. These were 2 demonstration spacecraft, so they're not commercial systems. They weren't serving any clients. Part of that was a regulatory reason and a timing reason. So in the US, there's a lot of licensing agencies you have to go through to get onto orbit. One of the longest lead ones is your communications license with the FCC. And if you don't have commercial business on your spacecraft, you can get an experimental license, which moves through much, much faster. And for us to really mature conversations with our customers, we needed to put something in space. It's great to have a PowerPoint spacecraft, but to be able to say, here's what we built, here is it in orbit, was something that's validating for those customers. So we wanted to get on orbit as quickly as possible. So mission 1, launched 2 spacecraft. It's been a rocky road. The mission was, it had its challenges. I'll say everything that Atomos built performed exceptionally well. But we had some issues with a few vendor provided components that made the mission quite challenging.
Yeah. And I can only imagine the anxiety of having that launch. You're putting on someone else's rockets to go to space. How was that?
We flew on SpaceX and, they have quite the heritage at this point. It's a pretty reliable ride. We had some offers for more discounted rides on newer entrants, and I didn't want to take that kind of risk. We like exposing ourselves to a little bit of risk and are definitely at the forefront of our developments, but I wasn't going to take that much risk. However, it was still nerve-wracking, So I remember that launch day, Vanessa was at Vandenberg. SpaceX had a VIP launch party. She was there with a few other team members. I was back here with our kids and the rest of the team, and we're sitting in our lobby. The SpaceX live stream is on the TV. And we were lucky enough that our spacecraft were front and center during the live stream. So we were watching and watching, and then we can see our 2 spacecraft separates, and everyone just starts screaming and cheering. And we've separated from the launch vehicle. We're in space. Our 9-month-old just starts wailing because everybody's screaming and it's so much noise, and he's crying. But it was a great moment.
Very cool. And so in concept, then you've got to develop. As I looked at this, some of the challenges seem like if you're moving around in space a lot, so you're traveling to another satellite to move it, and then you're going to travel to another one. First of all, why do these need moved? What are the use cases of where you see these other satellites need to be moved?
Yeah. So the markets we're pursuing and kind of the use cases have evolved a little bit over time. So when we started the company, we were heavily focused on what I would call initial deployment. So you're looking to put spacecraft into orbit. And instead of buying a dedicated launch vehicle just for your spacecraft, we were predicated on you could fly on these big transporter missions with SpaceX, where a lot of people go up at once to a standard drop-off point, and then we're going to rendezvous with you and take you to where you actually needed to go. Because spacecraft have their own propulsion systems, especially the ones operating in low Earth orbit. They're not designed to do a lot of maneuvering. They can do small maneuvering, but really big changes are outside of their capability set. Now, some of what we're pursuing has evolved over time. So we're talking to quite a few customers in the geostationary Earth orbit, so 36,000 kilometers away. This is your telecommunications operators. A lot of US government satellites are located there. And for them, some of them want to be relocated to new areas. They want to serve a new mission set, but they don't want to consume their own propellant. So they're looking to outsource these big maneuvers to companies like ours. We're in the process of signing a contract with a large telecommunication operator, a legacy operator. We hope to wrap that up in the next few weeks. And for them, it's about keeping them in their operating box as that spacecraft runs out of propellant.
And so to do that, I imagine you go through propellant.
Yep.
Rapidly. We've had some folks on from companies that do refueling. Do you have that capability? Have you partnered with, and who are those partners in China?
We developed a refueling capability in-house. So we do have a refueling interface for our spacecraft. We did look at some of the existing options and some of the companies that were doing it. I think because we go through so much propellant, we had some specific design requirements for our interface where it's, mass flow rate was critical for us because we couldn't spend days refueling because every day is quite a bit of revenue. So we wanted to pump a lot of propellant through. And we also were using, at the time, a fairly unique propellant. Our commodity was ammonia. We've since transitioned away from that, but nobody else was looking at ammonia at the time. So it was very bespoke to us. But we're open to partnering with folks going forward. I think it's going to require a robust ecosystem where there are refueling depots, logistics vehicles, and customers all working together to really reduce the cost of these services.
What propellant are you using now?
So we're now using xenon.
Okay.
Part of this was when we first were designing this mission, this was early days of Ukraine, which is one of the main suppliers of xenon. And the price of xenon just went through the roof. And, we were in 8 figures of xenon costs just to refuel the spacecraft. And it was just cost prohibitive. But it's come down quite a bit since then. So we're rebaselining using xenon.
And then with the use case that you mentioned, that's how you started your company. Where are you seeing the industry changing for the need to maneuver satellites?
So it's more in the geo servicing. Kind of talk through a little bit of the use case for them more. So if you're a geo telecommunications operator, you have gravitational forces from the moon, from the sun, you have solar pressure from the sun, and all of that perturbs your orbit and you slosh around a little bit. Now, they consume propellant to remain in their specific slot because some of them have tight operating boxes where they need to be exactly here to hit the antenna they want to on the ground. So the limiting factor for most of these missions is propellant. Now, when we started with initial deployments, there were a lot of startups building constellations. Then you had the 2001 period where financial markets weren't so happy as they were in the early 2020s. And private markets were drying up, interest rates were going up, and the constellation providers who had capital to build a constellation really didn't want to take risk on their deployment. They said, this sounds great. Love reducing cost. Talk to us when you've done this a few times. Conversely, you had these telecommunication operators who have $500 million assets in geo. They are running out of propellants. They are coming to the end of their lives. And they're also looking at SpaceX setting up Starlink, taking away customers. So they have $500 million CapEx expense coming due, declining top line revenue base. They are looking for any way they can to extend the life of that asset. So it became a financially driven reason that we started to pivot to geo, because for them, if we could charge, depending on the mission, let's say $7 to $20 million to extend the life of that asset 1 to 5 years, that is a no-brainer from them from a financial perspective, especially if it's, $50 to $75 million a year revenue that asset's generating. That's an easy financial decision.
That is interesting. I didn't think about that. The changing demand signal for telecommunications with SpaceX and the constellations.
Yeah. So it's interesting because when Vanessa and I started, I feel as though legacy operators wouldn't give an in-space servicing company, an upstart like us, the time of day. And in 2023, we were at Space Symposium and we were, doing customer meetings, a lot of palm pressing as you do at Space Symposium. And the mood shifted quite a bit. And it started to be transition from, oh, that's nice, that's an interesting idea, to when are you going to be on orbit?
Yeah, changed that fast.
Yeah, it was pretty fast.
So starting a space company, and getting something to space can't be a cheap endeavor. How did you guys get the capital? Did you go through VC funding? Like, how there's some of the business side of it. How did you do that, and what were the challenges?
Yeah, so we've raised 3 rounds of funding to date, a little over 26 million total. We are currently raising a $50 million Series B. It was challenging. I think though I came from a finance background, it was really wealth management. I did analysis on public equities, wasn't really involved in the private market, didn't know a lot of private investors. Vanessa didn't come from that kind of a background. And that first fundraise, there was a lot of learning on how you pitch VCs, how we position the company. I think what really changed the trajectory of that early fundraising process was we applied to Techstars and then got into Techstars in the Boulder program. And it was almost as though that became your USDA grade A beef stamp, because, well, if Techstars validated that we are legit, then we seem like more of an investable opportunity. And that catalyzed kind of our first fundraise. We did a little less than $1 million from some small investors, and then built the company from there. We've also done about $5 million in government contracts, mostly in the SpaceWorks, AFWorks kind of innovation, and we're looking towards bigger opportunities in the future.
And so, yeah, you are finding potential traction with government contracts and their need.
I would say we had good traction with the innovation stuff, and it's similar with fundraising, with customer business development. It's just building the relationships, finding who we need to know to get to the next phase. I think one of the challenges that we've seen, or something I've learned through this process, is it's more siloed than I expected in national security space, where you have, say, if you broke into 3 buckets, innovation units, then you have large scale RDT&E procurements, and then you have operational assets. And the correlation of traction from one bucket to the next is near zero. There's not a lot of communication between those, and it takes quite a bit of work to make it through that funnel.
And so do you do this on your own, or have you brought in a partner to help navigate this?
We've done most of it on our own. We do have a few consultants who help, be boots on the ground to identify opportunities. We've been working a little bit more with somebody right now who has a TSSCI, because I think that's another thing we've struggled with. Atomos does not have a facility clearance, and one of the things we are best at is rendezvous and capture. And the ability to rendezvous and capture space assets becomes classified very quickly. There's not a lot of unclass rendezvous work in the DoD.
No, I can't imagine there is.
Yeah, yeah. So there's one consultant, he does have, his TSSCI, and he's been kind of sourcing opportunities. And I do think we'll eventually go in that direction and, push to have a facility clearance and start doing some of that work. But that's a process in it of itself.
And so you've got your test satellites, or that you've launched, mission
Yep.
one. What's the roadmap for your follow-on capability set to be launched?
Yeah. So the customers that we have in final contracting, we've gone through a few red lines back and forth. This will be for an early 2026 mission. So they'll be pre-funding some of that, but we're also raising the Series B to capitalize that. We are currently working on the next spacecraft, which will launch at the end of 2025. This will be a fully commercial system. It's going to launch to GEO and start providing commercial services in that orbit. Ideally, it will have a 5-year lifetime. Goal is 10 years, but this will be our first spacecraft out in GEO. Radiation is no joke. And, we're developing a lot of things in-house, and we're just going to see how they hold up on that mission and have lessons learned for the next spacecraft that goes up.
Yeah, where are the biggest blockers for that? Is it just the unknown of how your system operates in that, or where are the biggest risks?
A lot of it is going to be in lifetime of components as they're exposed to radiation. So the lifetime of the solar arrays, we are working with a vendor who does have a technology where they anneal or they heal themselves over time as they're exposed to radiation. But typically, radiation degrades the solar cells, and their end of life power generation is quite a bit lower than their beginning of life. Other things are, because we rendezvous, having cameras is very important. So we have visible, infrared, and we're using a ranging sensor. Glass, cover glass, just ordinary glass that you could buy commercially, darkens over time when exposed to radiation. And space qualified versions of these are very, very expensive. So we are looking for ways to kind of create our own systems that we are space qualifying ourselves and seeing how they hold up. And then the last part of that is making sure our flight computers are robust enough, because as they get hit by particles, high energy particles, it does change zeros into ones and ones into zeros. And if that happens at the wrong time and it can't account for that, you could end up with a dead spacecraft pretty quickly. Because you can't exactly go up there and say, I'm going to push the power button and just restart it.
Right. How challenging is the comm infrastructure, to be able to communicate, be able to move it, be precise with that? You said there's some lag.
The challenge is a few-fold and for different reasons. So I'll say our mission one of the biggest challenges we had was communications. So because we do rendezvous, a critical thing is to have near constant communication during the rendezvous procedure. Now, it is human on the loop. It's not human in the loop. So we're not driving with a joystick, but we are monitoring it so we can hit abort if it reaches an unsafe state, because we don't want the two crashing into each other. So how that's historically been done is daisy chaining a bunch of ground stations around your orbit so that you can just hop from ground station to ground station. That is very expensive, and we're a startup. We're all about doing things cheaper. So what we used was a space-to-space communication. So instead of going down, we actually talk up to Iridium, that's a constellation just above us, and then Iridium talks back down to us. So we could communicate with it no matter where our spacecraft was, because there'd always be an Iridium spacecraft. The challenge that we had in mission one, and we learned this while on orbit, was that we launched in direct opposition to Iridium. So as we're going up, they're coming down, and our passes were about 14 kilometers per second. We were passing each other. For context, a bullet travels at 0.8 kilometers per second, and we're doing 14. So we are flying past each other. Now, the challenge is, so you have Doppler shifting, similar to how when an ambulance goes by, that happens with radio waves. Antennas are designed to accommodate that. But what we learned in orbit is that the band we were operating in was highly regulated and had a 9 km/s cap. So anything above 9 km/s, the radio would reject. So those 14 kilometers, it was as though they never existed. So we could only get in contact when we were at the poles. So what we're doing creates a new difficulty in communication. Then I think as we move out to geo, the next thing is that spectrum is a very rare resource. You have to go through a lot of process of making sure you're not interfering with all the legacy people because you don't want two bands to interfere with each other. And it can take quite an effort to convince all the regulatory agencies involved that, no, we're not going to interfere with anybody. We're going to be okay in this communication. And we could turn the radio off when we get to this point and turn it back on when we get to this point.
Interesting. So I understand your value proposition to the industry, but how about, what's your value prop or your differentiator from other, in-space propulsion systems that are doing similar things?
So, do you mean to our direct competitors or maybe just some of the other propulsion providers?
Probably both. I'm just curious, are you doing something uniquely different than other folks that are, in your similar space, competitors?
Yeah. So for our competitors, I think Northrop is probably the biggest competitor that we have for this geo servicing. They have what is called a mission extension vehicle through their subsidiary Space Logistics. I think our biggest differentiator is our time to orbit and cost. We have a spacecraft that is significantly less expensive than the Northrop spacecraft, and our lead time to say, yes, we'll be on orbit is significantly shorter, which has been very attractive to customers because they want to shorten their decision cycle quite a bit. Another thing that I think is unique in how we're solving it is we are pretty vertically integrated. So Mission 1, those two spacecraft were built almost entirely in-house. So we did everything from the structure, flight computer, flight software, rendezvous software, docking interface, propellant feed, avionics. All of that was built by our team with just 30 people.
That's impressive.
Yeah, we have an unbelievable team. They're just crazy good at everything that they do. We think that is the way we're going to solve this long term, is we can really control a lot of aspects of the spacecraft. We intimately know a lot of aspects of the spacecraft. Then the last thing I would say is our long-term vision. So when Vanessa and I started Atomos, our legal corporate name is Atomos Nuclear and Space Corporation. We originally used to go by Atomos Nuclear. Quickly learned during our first fundraise that being a space company and a nuclear space company was very hard to get meetings with investors. Nobody wanted to meet with us. So we decided to do a DBA filing, doing business as Atomos Space. All our branding changed to Atomos Space, but we are still looking towards space nuclear. I think that is the way to really solve in-space logistics and maneuvering, is have very high power systems. So we've been involved in nuclear studies with the government. We did 2 nuclear experiments this year. It's a small part of our R&D spend right now, but it is still a part, and it is still something we are planning to do.
Yeah, that does seem like it would definitely change the capability and price curve if you do it appropriately.
I mean, we can do a low Earth orbit to GEO, LEO to GEO transfer for a small spacecraft, 500 kilograms. With nuclear, we could do it with a 5,000 kilogram spacecraft in, the order of like a week. And that is just a game-changing technology.
Yeah, well, that is a big difference. So developing, mostly vertically integrated, produced spacecraft, what are the biggest challenges with actual spacecraft manufacturing?
I think our biggest learning from Mission 1 was vendor management and vetting. As I mentioned, the 2 issues we had on Mission 1 were with components. And I think because everybody was moving really, really fast and everybody is doing 12 different things at once, we didn't have a rigorous process in validating what testing vendors had done. When you say you did lifetime testing, what does that mean to you? Because it might mean something different to us. And learning some of that after the fact, that those two don't mean the same thing. That's probably the biggest challenge we had. And then, just the being so involved in the spacecraft, we got very good at being able to juggle the schedule and just being adaptable to change. Because there was a lot of times, all right, this vendor component's going to be late. So we're going to try to integrate this part of the spacecraft first and figure out how we're going to integrate that other part of the spacecraft later because, they're running 2 weeks behind on their schedule.
Yeah, especially in the startup world. I mean, everyone is wearing multiple hats. That has to be, you have to make some assumptions at some point. But yeah,
I think we did amazingly well for mission one. I mean, we did so much in-house and we demonstrated so much of that on orbits that I am super impressed with what the team has done. Our customers have been incredibly impressed.
Sure.
I think it's been just even better for some customers that we had some issues and how we overcame some of the problems to show the resiliency and the creativity of the team and how well we understood aerospace engineering to be able to say the communication problem, how we were able to overcome that in those early days.
That is kind of neat. It's almost like the wild, wild west, space of just how quickly you can change and adapt and move.
Yep.
And I like the approach. I mean, the ability to, you hear it used with the fail fast, you guys were able to get something out there, really identify things that needed to be fixed, but it's not slowing you down. It wasn't all eggs in one basket. So that's pretty neat.
Yeah. I like to think that we do really well of not suffering from sunk cost fallacy. If something is not working, even though we could have invested quite a bit of money, we cut it off pretty quickly. As a quick example, we've gone through 2 bus vendors. So we had one bus vendor a few years ago. We spent some money with them. That wasn't working out. We terminated. We then started working with another bus vendor. That again wasn't really working out, at least to what we wanted it to be. And that's when we decided, let's just do this ourselves. And we brought everything in-house. Even though we had spent for both of them, well into the 6 figures. As a startup, that's quite a bit of money. We go, this is just not a viable solution long term. We need to figure out something else.
So as you've done this startup in the space, what do you see are the most significant challenges that face SMBs in this industry to build technology and serve the government sector?
I think going back to what I said earlier, and it's really understanding kind of this, at least in space, I can only really talk about, space, this siloing of kind of units and how they think about things. And the mentality of those 3 different buckets is just so different. And I think even in our early days, we really took for granted. So we closed our pre-seed, we hired some people, and then I think the next big break for Atomos was we won a $1.5 million phase 2 with AFWorks, looking at a vehicle to be maneuvering around in orbit. And we thought, man, we're crushing it on this DoD stuff. We're like experts now, procurement contracts, here we come. And we learned that, especially in DoD land, $1.5 million, while a lot to us, is rounding errors, to say the least. And we just didn't have the network at the time to really mature that and take it to the next level. And it's learning that within U.S. government procurements, if you don't have just an incredible network and know some of these folks, you've already lost. Your competitors, if they do know these people from the earliest stages of the ideation, they understand some context in the solicitation that you don't have. And you are at such a material disadvantage putting together your proposal, and you'll just be chasing opportunities and it's not going to pan out. I think, to me, that's been the biggest learning, one of the biggest challenges. And, what we're still just trying to figure out, what's the best way to solve this problem.
Yeah. Well, it's definitely good to have that dual use, if you will, so that you can continue to fund until you align yourself with that government.
That is what we have done, I say more purposefully over the last 12 months, more 18 months, is we kind of shifted our mindset of instead of trying to figure out what the government wants us to build, we're just going to build what we think the best solution is, focus on commercial. And then once we've demonstrated capability on orbit, say, all right, US government, this is what we have. You don't need to fund any development. We already have this. It's already operating. This is how much it costs.
Yeah, I hear that a lot of, especially space, because it is so new, and they're standing up new capabilities, different acquisition, but driving them to the solution they don't know what they can even do, and the cost to do the R&D vice a company like yours can bring that capability is very advantageous.
Yeah. And it's why from the earliest days, so when Space Systems Command, the Launch Enterprise Group, they were doing RFIs for national security space launch phase 3, and we would always respond to it. And we would always request one-on-ones during the industry day. And they would always say, you are not a rocket. What are you doing here? And we go, okay, but space logistics. This is how you expand launch vehicles. And we did that all the time. And we saw huge value in that because we're trying to communicate where we think the market is going, where they should be looking, knowing that this is not going to result in a solicitation for OTVs in the next 12 months. But, it's a long game. And we got to start putting it in their mind that this needs to be part of the trade space.
Great. You're not a rocket company. Go away.
Yeah, we said that. We've been told that explicitly more than once in those meetings. Yeah, I know. We don't build rockets.
Just hear me out.
Yeah.
Let's get. So where are you guys going to be in the next 5 years? Like any particular milestones or key initiatives that you're super excited about?
Yeah, I mean, in the next 5 years, I would say we have a few spacecraft in orbit. We are servicing GEO operators and LEO operators, and have a team, let's call it well into the hundreds, 200, kind of building spacecraft in-house. For us, the next really big milestone is we'll call it the next 24 months, which is going to be getting that first commercial system up and operating and really start generating revenue. In a perfect world, I would love for this to be our last equity fundraise. And then every spacecraft we build from this point forward is, built off of our revenue.
Yeah, that would definitely be exciting. And then any lessons learned as you've entered into the entrepreneurial space, entered into the space that you would, that have shaped your leadership style and the culture? Like, how best would you think of that? Because it's been a lot of growth, I imagine.
A lot of growth, a lot of ups and downs. I think it comes down to hiring and how we've done so much with so few people. One of the things we learned, or the mistakes we made early on, is hiring for resumes is a horrible idea. Sometimes it was almost catastrophic when we thought, oh, this person has a great resume. They're going to make us look very mature to our customers. And I shouldn't even say rarely, that never worked out. And
were these like folks that had big names working in big companies, so they're used to bureaucracy and
yep
teams to do things that I've got an idea, like, great, go do it yourself. You don't have a team to do it.
Yep. And even, taking it one step further, what we've really learned in the interviewing process is trying to flesh out, was this person a spectator in their career, or were they really an active participant? Looking at some of the things they were involved in will tell us about how were these decisions made? How did this get across the finish line? And if they can't answer these, oh, well, I was handed a sheet of specifications and that's what we did. That's not going to be a person who fits here. And then the other thing, which has really become a bit of our mantra, is the only way to create culture is through who you hire, fire, and promote. And everything else is just filler. You can have all the culture activities or culture documents you want, but it's those 3 things is really critical. And I think that the hiring is obvious. A lot of people know about the hiring. Promote, somewhat obvious, but I think not cared for enough as the firing, because nobody loves to fire people. But
Right.
it is really important on, if somebody's not working out, it's the best for the company and usually best for that person to just say, this isn't working. I don't think you're a good fit here. You'd probably be happier somewhere else.
Yeah, I definitely think that's great advice. And it's hard, especially for small business. It's just a drain. It's killing your capital. It's killing the motivation, the excitement.
Yeah, I mean, when you're only 30, 40 people, letting somebody go can have ripple effects, and like they're never easy decisions. It's not something we want to do, and there's, unintended consequences we have to think through, and how will everybody react to this? Is, this a good decision for morale as well as productivity?
Great inputs. Well, this has been a blast.
Yeah.
Unfortunately, we're gonna have to go wrap this up. I know Vanessa was supposed to join us, but give her our best. And
Yeah.
really appreciate it. I'm excited about what you guys are doing. I think you're tackling a very unique problem and have uh, a unique opportunity to really be successful. If folks want to, kind of follow what you guys are doing, how's the best way for them to do that?
Probably on Twitter. That's where we're most active. At Atomos Space is, where we do most of our updates.
Okay. Well, that's great. Well, thanks again. Enjoyed it. And let's stay in touch.
Thank you. Yeah, it was fun. Pleasure being on.